Good morning, everyone. Here I would like to present my paper titled Machine Learning Algorithms for the Segmentation of Brain Tissues, a Bibliometric Analysis. Myself, Dr. Kumar, working as professor in the Department of Electrical and Electronics Engineering, Amalajodi College of Engineering, Kanjirapalli, Kerala. So these are the contents of my presentation. It comprises of introduction, materials and methods, publication trend details, country specific research, local and global citations, international collaborations, and finally conclusion and references. First of all, I would like to give you a brief intro about my work. Actually, this research work comprises of a detailed bibliometric analysis using R software on the domain machine learning models for brain tissue segmentation. So it's a general thing that for analysis of neuro disorders, MR images will be taken by the physicians and radiologists. From the MR images of brain, the segmentation of white matter, grey matter and cerebrospinal fluid plays a vital role in the diagnosis of neuro disorders such as Alzheimer's, schizophrenia, Parkinson, epilepsy, multiple sclerosis as well as tumors. Not only for analysis but also for the prediction of the neuro disorders. So this bibliometric analysis is a exclusive literature survey focusing on how many papers have been published on this domain and which are the countries those had contributed a lot in this research domain. All the analysis was done by R software language and the details for this bibliometric analysis were downloaded from the Scopus website. So let's start with the materials and methods. First of all, I had highlighted the table 1 that represents the bibliometric data used for the analysis. I had taken the bibliometric data from the year 1990 to 2024. On a total of 188 sources were considered that comprises of journals and books from peer-reviewed publications. Totally 685 documents were there and the remaining details represents the characteristics of the data what I had taken for the bibliometric analysis. Document contents are there, author details are there, then author collaboration details are there. The publication trend analysis using R software was represented by a graph and it is represented in the figure 1 that represents the publication trends over time. Actually, the publication trend represents the count of annual publications of articles from 1990 to 2020. The x-axis represents the years and the y-axis shows the number of publication. Actually, this graph, that's the publication trend, demonstrates a growing interest in the research area in this domain, especially brain tissue segmentation. The average citation graph is represented in figure 2. It comprises of the total number of citations in each year from 1990 to 2023. The graph shows here drastic fluctuations and has a peak values around the years 1993, 1997 and 2004. The number of citations then declines from the year 2004. The three-field plots of the scientific work is represented in figure 3 and the three-field plot of scientific work comprises of the relationship between cited references CR, authors AU and the descriptive keywords DE. The lines connecting different columns demonstrate the pattern of association between frequently cited authors and specific areas of research. The country scientific production of this research work is represented in figure 4. It represents systematic and scientific production of various countries in a world map using color gradient based representation. You can see the color variations from the figure itself. This pinpoint global imbalance in scientific contributions indicates that United States, parts of Europe, India, China and Brazil and Australia are the leading contributors in scientific production, specifically on this research topic, that is machine learning models for the segmentation of the brain tissues. The most relevant sources graph is represented in figure 5 and the x-axis represents the number of documents and y-axis lists the different sources of journals. For visual representation, I had cut short the y-axis representation. The relevant source that's found to be more cited is IEEE Transactions on Medical Imaging with 57 documents published and other relevant sources include medical image analysis, computerized medical imaging and graphics. Actually, the relevant sources graph emphasizes the key journals in which most research works in the field are published. The core sources of this research domain are represented as per Bradford's law in figure 6. Bradford's law is used for estimating the exponential distribution of articles across the journals. Article count is represented along the y-axis, whereas the source log is represented along x-axis. The fewer sources that contribute to a larger percentage of articles are stamped as core source and is labeled as the shaded area. Source local impact demonstrate the H-index or impact measure. The source local impact is represented in figure 7. Vertical axis represents the various journals and the horizontal axis represents the count. Each blue dot in the graph represents the impact measure value that varies between 0 to 40. The scatter plot shows the number of documents corresponding to the different authors. X-axis contains the names of the authors and Z-axis contains the number of documents. The productivity of each author can be easily highlighted using this figure. The most relevant authors graph is represented in figure 9. Lesser authors contribute larger number of articles and a majority authors contribute very less works. The x-axis shows the number of articles varying from 0 to 60, whereas the y-axis records the institutions such as University of Oxford, University College Education of London, etc. So the y-axis represents the affiliation details. The affiliation production over time is represented in figure 10. The article publishing rate of well-known universities is presented from 1996 to 2021. The x-axis denotes the years varying from 1994 to 2024 and the y-axis lists the number of articles ranging from 0 to 60. Each line with a different color represents various universities. The corresponding author countries is represented in figure 11, a horizontal bar chart showing the number of documents attributed to corresponding authors from various countries. The bars are segmented into three colors representing different types of collaborations: red for collaboration, teal for MCP and light blue for SCP. This graph visually represents research output by country and highlights pattern of international collaboration. The affiliation production over time is represented in figure 12. X-axis contains the year and y-axis denotes the number of articles ranging from 0 to 60. Each country's article production scenario is plotted in different color. Steady, uniform and sustainable growth is exhibited by the country USA. Most cited countries graph is represented in figure 13. X-axis showing the number of citations ranging from 0 to 4000 and y-axis denotes the countries. USA has the most and the highest number of citations, that amounts to 4129, accompanied by China with 2611 citations and India with 933 citations on this research domain. The local and global citation details are represented in figure 14 as well as in figure 15. X-axis represents the global citations as well as the local citations and y-axis represents the author details along with the publication details. And this indicated that the popularity and global acceptability of document on the basis of citation count. The reference spectroscopy is represented in figure 16. The trend in cited references over time is represented as a reference spectroscopy. The horizontal axis labels the year and vertical axis denotes the cited references. The graph dictates a tremendous rise towards the right end, showing the increased number of citations. The country's collaboration on the world map that we can term as international collaboration is represented in figure 17. Level of collaboration between countries are represented using the shades of blue, with higher level of collaboration is represented using darker blue shades. Collaborative or partnership efforts are indicated using red lines connecting different countries. Now comes to the conclusion of this research work. The bibliometric analysis presented in this study provides valuable insights into the development and influence of machine learning algorithms in the field of brain tissue segmentation. The findings reveal the interest in this area has significantly grown over the past 3 decades, driven by the rapid advancements in medical imaging and artificial intelligence. Key contributors include influential journals like IEEE Transactions on Medical Imaging and renowned institutions such as Harvard Medical School and University of Oxford. The highlighted gaps and trends suggested opportunities for enhanced international collaborations, increased focus on underrepresented areas, and further exploration of emerging machine learning techniques, especially deep learning models. In the current scenario, a lot of new user-defined and tailor-made deep learning models are coming, and future works will be focusing on those tailor-made deep learning models for the segmentation of white matter, gray matter, and CSF. These are the references what I had used for the preparation of the research paper as well as the presentation. The references are continued in this slide also. These are the final list of references what I had used for my presentation. Thank you. Thus I had came to the end of the presentation. Thank you all for listening.